EGR 6163, Project Management, Module 5, Lecture 1, Estimating Project Times and Costs. Learning objectives for this module are to understand that estimating project times and costs is the foundation for project planning and control. We'll describe the guidelines for estimating time, cost, and resources. We'll describe the methods, uses, and advantages and disadvantages of both top-down and bottom-up estimating methods. We'll distinguish different kinds of costs associated with a project, and we'll define a white elephant in project management and provide examples. The reading assignment is Larson, Chapter 5. So first of all, what is estimating? Estimating is the process of forecasting or approximating the time and cost of completing project deliverables. It's a trade-off, basically, balancing the benefits of better accuracy against the cost of secured increased accuracy. They're typically classified as either top-down or bottom-up. Top-down estimates are usually done by senior management. Management will often derive estimates from an analogy, a group consensus, or some kind of mathematical relationship. On the other hand, bottom-up estimates are typically more accurate. They're typically performed by the actual people doing the work. Their estimates are based on the work breakdown structure. So why is estimating time and cost important? Well, primarily, estimates are needed to support good decisions, to schedule work, to determine how long the project should take and its cost, to determine whether the project is even worth doing, to develop cash flow needs for the company, and finally to determine how well the project is progressing, because you can compare the actual cost to the estimated cost to see if you're overrun. So what's the kind of factors influence the quality of estimate? Well, first, we have what's known as the planning horizon. The planning horizon is actually just, how far out in the future the project's actually going to occur, because typically the quality of the estimate depends on the planning horizon. Estimates of current events are close to 100% accurate, but they become less and less accurate for more distant events. For example, cost estimates for a party you're organizing this weekend should be much more accurate than the estimates for a party that will take place 6 months from now. Now, imagine how difficult it would be to estimate the total cost of a 4-year transportation project. The accuracy and cost estimates should improve as you move from your conceptual phase to the point where individual work packages are defined. Also, complex projects are harder to estimate than simple projects. People factor, the quality of the estimates really depend on who's actually doing the estimate and the skills of the people making the estimates. It also depends on the project structure in the organization. Who's going to manage the project? One of the major advantages of a dedicated team is the speed gained from the concentrated focus and localized project decisions. Another thing is that you can run into is what's called padding estimates. Padding estimates is the practice of adding a fudge factor, which sounds like a good idea, but actually it makes it much harder to get good, reliable results. So typically padding estimates are discouraged for that reason. Another factor is the organizational culture. Some organizations are much better at doing estimates than others. This can significantly influence the project estimates. There are many other factors that you can add to this. This is just the textbook's factors that he considers. So estimating guidelines for times, cost, and resources. The first one is responsibility. So at the work package level, estimates should be made by the person most familiar with the task. They will give an estimate based on experience and best judgment. A secondary benefit of using those responsible is the hope that you can get them to buy into the project And when they do that, they'll give much better results. The second one is guideline is to use several people to estimate. A cost or time estimate usually has a better chance of being reasonable and realistic when several people with relevant experience or knowledge of the task are used, because they can compare notes. Thirdly, you want to use what's called normal conditions. When a time, task, cost, or resource estimates are determined, they should be based on certain assumptions. These estimates should be based on what's called normal conditions, efficient methods, and a normal level of resources. For example, if the normal workday is 8 hours, the time estimate should be based on an 8-hour day. Similarly, if the normal workday is 2 shifts, the time estimate should be based on a 2-shift workday. So what that means, so the normal conditions, is what your company's doing every day. That's what you want to use for the time and cost and resource estimates. Fourthly is the time units. Specific time units to use should be selected early in the development of the project. All time estimates need consistent time units. Estimates of time must consider whether normal time is represented by calendar days, work weeks, person days, single shift, etc. In practice, the use of work days is the dominant choice for expressing task duration. Estimators should treat each task as independent of other tasks that might be integrated by the work product schedule. Work package estimates should not include allowances for contingencies. The estimate should assume normal or average conditions, even though every work package will not materialize as planned. For this reason, top management needs to create an extra fund for contingencies that can be used to cover unforeseen events. So it's obvious that some tasks carry more time and cost and risk than others. Number 7, risk assessment added to the estimate to avoid surprises to stakeholders. And this, a lot of different, when you compare doing a lot of different work packages, this can be something you need to consider. For example, a new technology usually carries more time and cost risk than something you've been doing, you've done 100 times. So identifying the degree of risk lets stakeholders consider alternative methods and maybe alter their decisions. So top-down, let's talk a little bit about top-down versus bottom-up estimating. Top-down estimates are usually derived from someone who uses experience and/or information to determine the project duration and total cost. They're sometimes made, again, by top managers who have very little knowledge of the component activities used to complete the project. Bottom-up estimates can take place after the project has been defined in detail. They can serve as a check on cost elements in the work package schedule by rolling up the work packages and associated cost accounts to major deliverables. They provide the customer with an opportunity to compare the low-cost, efficient method approach with any imposed restrictions. Now, a lot of times what happens is that these two methods are actually combined. Initially, the top-level management will do a top-down estimate, and as the WPS and OPS are developed and pushed down to the work packages, they'll also do a bottom-up estimate by rolling up the work package cost, and then they can directly compare the two, and they can iterate and get a better estimate of the true cost. So, when you first start out, there's a lot of sound reasons for using either a top-down or bottom-up estimate, and our textbook gives us a little table, of when to use a top-down or bottom-up estimate. So for strategic decision-making, top-down is going to be the best. If cost and time are important, well, then you want to get the bottom-up estimate because that's going to be the more accurate. If you have a lot of high uncertainty, well, top down is probably best because, again, the bottom up is not going to give you a great estimate because it's very uncertain. If you got a very small project, top down is very good. If you got a fixed price contract, you want to do a bottom up because that's going to be more accurate. If the customer wants a lot of detail, well, that's when you need a bottom up estimate. You have very unstable scope, well, you want to do a top down estimate in that case. So the preferred approach, again, is, as I mentioned before, is to make rough top down estimates, develop the WBS and OBS, and from there use that to make bottom up estimates, develop the schedules and budgets, and reconcile the differences between the top down and bottom up estimates. So let's take a look at some top down methods for estimating project times and cost. So first we have what's known as the consensus method. This method simply uses the pooled experience of senior and or middle managers to estimate the total project duration and cost. It typically involves a meeting where experts discuss, argue, and ultimately reach a decision as to their best guesstimates. The second was what's called the ratio method. This uses ratios to estimate a project times or cost. You see this a lot in construction where they use, for example, the number of square feet to estimate the cost and time to build a house. For example, if a house of 2,700 square feet might cost $160 per square foot, you can simply multiply 2,700 feet by $160 per square foot, and you come up to $432,000. So that's as an example of the ratio method. Third method is the apportion method. This is sort of an extension to the ratio method. Apportionment is used when projects closely follow past projects in both the features and cost. Given a good historical data, estimates can be made rather quickly with little effort and reasonable accuracy. Another one is function point method. This is often used for software development. And I'll show you an example of this in a slide after this one to show you how this works. But it simply uses, when software you have a number of inputs, a number of outputs, a number of data files, a number of interfaces, and so each one of those adds up to the cost. The final top-down method is what's called learning curves. These are for, some projects require that the same task, group or task or product be repeated several times. So managers sort of know intuitively that the time to perform a task improves with repetition. This phenomenon is especially true of tasks that are labor intensive. In this circumstances, the pattern of improvement can be used to predict the reduction in time to perform the task. In other words, the more often you do a task, the better you get at it, and actually the cheaper it's going to become, cheaper in cost. So this figure shows an example similar to one you find in actual practice. Let's assume this is the apportion method for allocating costs that uses the WBS. So let's say the total project cost is $500,000, and we can use the percentages. So if design is going to be 20%, we can take 20% of the $500,000, which is $100,000, and then if the work package D1 is and D2 comprise all of the design, well, if we determine that D1 is 10% of this and D2 therefore is 10% of that, we can sort of divide this in half and get $50,000 for each of these work packages. So it's very easy to break the project down using the WBS and associating the cost with each of the at each level, level 1, 2, 3, and etc. And so you can actually break down this total cost into smaller and smaller pieces. So again, in the software industry, software projects are frequently estimated using weighted technique called function points or major parameters such as inputs, outputs, inquiries, files, or interfaces. So typically what you have a complexity weighting. So if it's low, average, high. So in other words, if the number of inputs is very complex, well then you'll multiply the number of inputs times 4. As the number of outputs is low, you would multiply the number of outputs by 3. And so you would add all these up on the right-hand side and come up with your totals. So here's an example for software project 13. They have 15 inputs. Rated complexity is low. So again, that's where the 2 comes in. So you have 15 inputs times 2, 30 over here. 5 outputs. Rated complexity is average, which is the 6. So you have 5 times 6 is 30. So you add up all these functions, and you get a count of 660. 660 for that. Now, how do you actually use this? Well, let's look at the next slide here that I made. So given this count of 660 function point counts, as it's called, and let's say that one person month has historically been equal to 5 function points. In other words, one person working for a full month could do 5 of these function points. So therefore, if you have 660 function points, if you divide that by 5, you get 132 person months to do this project. So let's say you have 10 programmers on staff. That you would roughly take 132 divided by 10 for approximately 13 months to actually complete this project. So let's say that if you got 10 programmers, they cost you $8,000 a month, let's say. Well, if you multiply 132 by 8,000, that tells you that your estimated cost will be roughly over about $1 million for this project. Let's take a look at some bottom-up methods for estimating project times. Remember, bottom-up methods are at the lowest level. These are estimating costs from the WBS at that level. First up is the template method. So here, if the project is similar to past projects, you can simply use that historical data to come up with a new estimate. There may be slight differences in the new project, but you can note those and you can adjust costs to reflect those differences. For example, a ship repair dry dock firm has a set of standard repair projects for overhaul, electrical, mechanical. They use those for the starting point for estimating the cost and duration of any new project. Next method is what's called the parametric procedures. This is very similar to the top-down approach of estimation, but it's applied to the work, again, the lowest level. So for example, let's say you have a person that's got a work package to wallpaper a room. He knows that it costs, the wallpaper itself costs $5 per square yard, and he can install it for $2 per square yard. So that's a total cost of $7 per square yard. So if you measure the length and height of all the walls, you can calculate the cost simply by multiplying that square footage by 7. So it's easy to do that. The last method is what's called range estimating, and this works best when work packages have a significant uncertainty associated with the time or cost to complete. So in that case, what you do is the person would estimate a cost, a low cost, an average cost, and a high cost, and those that would have kind of like a range of estimates for the activity. And so best case scenario, it costs less than the high case, and then they provide an average cost for kind of middle of the road kind of thing. So to provide an example of this range estimating, our book gives this example for this organic wine launch project. So here you can see you have the WBS numbers here on the left column, and you have the description of what actually that is. So 102 is like the approval, 103 is the design packaging, and in each case they give a low estimate, an average estimate, and a high estimate for the number of days to complete that project. And they also give what's known as a risk level. This risk level is sort of, how certain the confidence is of this kind of thing. So here you can use the number of days again and multiply by the cost of actually per day of who's doing the project or the particular work package to roll up a cost. So this risk column again is it's kind of like an independent assessment of the degree of confidence that the actual time will be very close to the estimate. So in this example, work packages, for example, of the ones that say like high, like 104, 108, 110, 111, and 114 have a high chance that the average time may vary from this expected value. On the other hand, the ones that are low, 102, 105, and 112, the group feels that the risk of work packages, not coming in at that low cost is very low. The final approach is we'll talk about what's called the hybrid approach, what's called phase estimating. This is used when you have an unusual amount of uncertainty surrounding a project, and it's really impractical to estimate times and costs for the whole entire project. So the cost estimating is done in phases over the lifetime of the project. So here, you break the project into different phases, and you make estimates during each of those phases. A lot of times these projects are often found in like aerospace or new technology projects. You use these phase estimating techniques are used. So here, what happens is that when the project need is determined, for example, you make what's called a micro estimate, a very quick estimate, and then if you go to the next phase, you make a more detailed estimate based on the macro estimate. As you go through the project, from the need to the specifications to the design, you repeat this project, and as the project progresses and as the specifications become more firm and solidified, your estimates are going to get better and better throughout the life cycle. So again, phase estimating is preferred by those working on projects where the final product may not even be known and there's a large amount of uncertainty. You sort of have to do cost estimating as you go and kind of refine it as you go along. So here's a summary of the differences between top-down and bottom-up estimates our textbook gives. It talks about the intended use for each of them, preparation cost. The author doesn't really say where he gets these numbers at, but bottom-up obviously is going to be a little bit more expensive, because you actually you got a lot more people working on work packages, rolling those costs up. The accuracy, of course, of bottom-up is going to be much better than the top-down estimates. And then he gives the different methods that we talked about.